All right, you guys, we are on the home stretch. This is the last video that's applied to polar complex. So ultimately, little celebration. Woo-hoo! All right, so here we go. A couple of review questions right here at the beginning. Ultimately, I am going to pause the video right here, show you the solutions to these, and then we can move forward with some of this complex cubed roots that we've got to do. So we're going to pause right here for just a second. And poof, we're going to get a whole bunch of solutions there, but let's kind of talk about where these solutions actually came from. Starting with the first one, the rectangular form of a polar form deal. See how it's got r's and thetas in it? We want to get those out and make it in more x and y terms. Writing it as a 1 over cosine for the secant is a great idea, and just cross multiplying and solving will get you that r cosine theta is equal to 1, and ultimately x is equal to 1 because r cosine is x. Next one, finding the angular velocity of a point traveling at 3 revolutions per minute. Angular velocity is measured in angle per unit time, so ultimately we don't talk about it in revolutions, and 1 revolution is 2 pi, so it makes sense to just multiply it by 2 pi, and it'd be 6 pi radians per minute. Number 3, this one happens to be one of the more missed ones that come from the polar unit, and that is finding the polar form of a line. This is super important to understand that makes a line. Lines are in the form of theta equals when you write them in polar form. So tangent of theta is equal to the slope that you're dealing with there. And then as we take the inverse of both sides, we'll end up getting the formula for it. Could be written in degrees or it could be written in radians. Depends on which way the answer is being focused on. But all lines that go through the origin should be written in terms of theta equals. That's one of those special cases that you've got to go look back for and pay attention to. All right, now today we're going to be tackling some more complex roots like we did on 6.3a. So a lot of this first part will seem very similar to what we saw in the actual previous video until I get to the solving piece, which is on the back of this page. So let's talk about finding an actual cubed root of the following question. So I'm going to take the following idea and I'm going to raise it to the 1/3 power, just like we did with DeMoivre's yesterday. And if I apply that 1/3 power on each one of these, it would apply to the power and it would apply as a divider to the angle. So we're going to get 3 cis of 150 divided by 3, which would be 50. Now, that happens to be the primary root, but unfortunately, since we're taking a cubed root, our expectation would be that there are 3 answers for this, and those 3 answers are going to be from the other angles of unity that you've got to come up with, and we've got to add on the portionality of 3 of 360. So in the other video, we did 2 pi divided by n for that, or you could actually think of it as 360 divided by n as well too. So it depends on whether or not your cis angle is being dealt with in degrees or if it's been dealt with in radians. Now, if I take 360 divided by 3, this would be a 120 degree addition so that I can get the angles of unity to be equally distributed around the first revolution. So this would be 3 cis of 170 and 3 cis of 290. Now, each one of those needs to be calculated in terms of what it is as a polar, from polar to rectangular. So let's start with the first one, 3 times the cosine of 50 plus I sine of 50. And then we'll take that question, break down each one of these individual 2, and distribute the 3 through it. So we're basically going to take the cosine of 50, and we're also going to find at the same time the sine of 50. And I don't know if they want the angle in degrees. Oh, they do. They want the angle to be in degrees. That answer is not going to be correct. I've got to make sure that my calculator is in degrees. So be careful on these questions. You're going to be flipping back and forth from degrees and radians depending on the situation. So cosine of 50 is going to be one of those. And we're going to take this answer and we're going to multiply it by 3. And that'll be the beginning part of this. This would be 1.92 plus, now we'll go back to our calculator again, and that answer, oops, I don't know why I multiplied it by 3 again. Then the next one would be sine of 50, and I could multiply that answer by 3 as well, and I would get 2.3 basically I, 2.3 I. Now, just to verify, that happens to be in the first quadrant. 50 degrees, first quadrant, positive, positive, first quadrant. Now, the other two are going to be calculated the same exact way. 3 cis of 170, and we're also going to calculate the answer for 3 cis of 290. Now, I'm going to pause the video and calculate these. I don't think there's really any issues with those. We'll just find out whether or not you can get those answers correct. Now, each one of those answers was calculated below for the 170 and the 290 angles of unity. Please note that we're definitely keeping track of whether or not we're falling in the same quadrant. 170, second quadrant, that would be negative and positive. That makes sense. 290 is in the fourth quadrant. That would be positive and negative, and that one looks like it agrees with the same idea. Hey, this complex root concept right here, definitely, I would say we're going to see it again, probably on a quiz or on a test. That's a really good question. Now, second one states that they want the argument angle in the 0 to 2 pi range. So being able to deal with it in terms of degrees or if it's in radians shouldn't really matter to you. You should be able to accomplish either one. I'm going to raise this entire DeMoivre right here to the 1/4 power, apply as a power on the front radius and as a multiplier on the angle. So 16 to the 1/4 is 2, and the answer here would be cis of 1/4 times that would be pi over 24. There's your primary angle. Now we've got to talk about what's the addition value that we need to add to get the angles of unity, and that would be 2 pi divided by 4, because we've got 4 individual angles of unity, which would be pi over 2. Now, I like pi over 2 as an answer, but it's not going to add on to pi over 24 relatively easily, so I'm going to change this into 24ths so that I have common denominator senses that will apply, and I can add these to get the other angles of unity, which should be 13 pi over 24. They should also be 25 pi over 24. And last but not least, that's a really ugly deal. Last but not least, it would be 12 added onto that, which is 37 pi over 24. And all of these are 2 cis's. 2 cis, 2 cis, and 2 cis. All right, there's your 4 angles of unity that are reflected at the complex roots for that deal. Each one of those would definitely be able to be calculated on a calculator form. We're definitely looking at 2 cis of pi over 24, and I'm going to do one of these because ultimately doing all 4 of them will burn up our time, and I'd prefer for you guys to be able to move forward and get the answers that you're looking for. So this would be 2 times the cosine. Now be careful. Our stuff is now in radians this time. So see a quick changeover to note what we're dealing with. Cosine of pi divided by 24. And that answer would yield 1.98. Whereas 2 sine, and maybe I could do this, second entry. And I'm just going to change this to a sine. See, you know, work smarter, not harder. And those would be the 2 individual values that we're dealing with here. 1.98 and 0.26. 1.98 plus 0.26i. Now, every one of these angles of unity has their own rectangular equivalent, and you'd want to calculate and punch those all individually out. That's basic calculator work, guys. Similar to what I just did right there for the first one, you're just going to calculate them for the others. Be sure that the answer that you get in rectangular matches the angle location of where it is in radians. That's key to it all. Okay. Now, the back side of this is the much more interesting side. And if I was going to go back to Algebra 2 without DeMoivre being a possible thing that I knew about, and Trig, which is what you're really good at by now, you would basically say that the answer for this question would mean that you would take the cubed root of both sides, and you would end up with x is equal to 3. Okay? Now, I'm not going to disagree with you in that regard, but I am going to disagree with the fact that from an Algebra 2 honors point of view, absolutely, that is a reasonable answer. It's on the real it's in the real world because it's a real number. Get that? That's funny. Okay? But it does not take into consideration the actual fundamental theorem of algebra, which means that the power that's associated there should be the number of answers that are possible. So, in terms of an Algebra 2 sense, yeah, that's good, but you're in Trig now, and you know DeMoivre. You know him well. That French man, he made things difficult for you. So what you'd want to be doing here is thinking about the x cubed could be written as 27 plus 0i. And if I was going to accomplish the power correctly, I would be raising this to the 1/3 power on both sides. And oh lordy, we have got ourselves a DeMoivre's power theorem. I'm loving this. Okay, so based on DeMoivre's, we would want to change this idea into polar first. And since it's 27 on the real axis and 0 on the I, it would ultimately just be a dot that would be over here. Now, in terms of polar, that would be our distance away, and angle would be 27, and it would be written at cosine of 0 plus I sine of 0, because it's on the 0 angle. All right, now we want to raise this whole entire deal to the 1/3 power, and let's see what we get out of DeMoivre's deal. This would be 3 cis of 1/3 times the 0 would still be 0, and 3 I sine of 0. Now, unfortunately, that is not the only answer. That's the primary answer, which is the one that usually yields you to the answer that you would get in real life, because cosine of 0 is 1, and 1 times 3 would give you 3, would be the primary answer. But the problem is that there are other unity complex answers that would work just as well. And those would be, oh yeah, we're going to have to add on the measurements of unity, and those measurements of unity would be 2 pi divided by 3 in each one of those cases. So this would be 3 cis of 2 pi over 3 plus 3 I sine of 2 pi over 3. And then I'd add another 2 pi over 3 on, and that'd be 3 cis of 4 pi over 3 plus 3 I sine of 4 pi over 3. Okay, these two answers are just as valid as the other two, and these two complete the fundamental theorem of algebra as well. Now, if you converted these to their rectangular forms, which is really what they're asking you to do, it says write your answers in polar, good job, and write your answers in rectangular. There's the rectangular for that one. These two would be the rectangular answers of negative 3/2, and that would be plus 3i root 3 over 2. And I got that one just on my notes because I just did the math. And then this guy would be, that one would be calculated distributing the 3 across each one, which would be negative 3/2 minus 3i root 3 over 2. You'll also notice that the two answers that come from the imaginary complex idea of this happen to be conjugates of each other, and they will be. That is not an uncommon precedent. So, based on really completing the ideas of the fundamental theorem of calculus, now, or of algebra, you should see that there really should be 3 solutions. How many real ones? 1 real one, 2 imaginary ones. And that actually completes that kind of idea. Number 4, let's try this. If it was a 4th power concept, it would make sense that we would probably see two possible answers that are in the, I think if we took the fourth root, we'd get plus or minus once we did it, and we'd get two answers of 3 and -3. So my thoughts are here is that 3 and -3 are definitely on the spectrum. But the question is, what does DeMoivre say about the other two? Well, the key is to write this n component as a rectangular complex. Boy, that thing just, it hangs me up. X to the fourth would be equal to 81 plus 0i. And if you write it this way, now you can start to see that you're really going to be taking the fourth root of that. Now I'm going to do a couple of things at the same time. Basically going to say that x is equal to, writing this in polar would mean that the distance would be 81. So this is 81 cis of, and since it goes only to the right, it would be cis of 0. Okay? That raised to the 1/4 power. Now that first answer would be the fourth listed on here, and that would be 3 cis of 0, not theta, of 0, of 0, oops, 0. And that would be your primary first answer. Now the other answers, which there's going to be 4 of, have to be equally spaced around that 2 pi interval. So it'd be 2 pi divided by 4, or a pi over 2 addition. And so the other answers would be 3 cis of pi over 2, 3 cis of pi, and 3 cis of 3 pi over 2. And that would give you all of the answers all the way around the first deal. Now, if you do each one of these, you'll see the answers that come out rectangular. Cosine of 0 is 1, so 3 times 1, plus 0 times I is going to be 3. There's one that we expected. Then we're going to get cosine of pi over 2 is going to be 0, so this would be 3 times 0, plus sine of pi over 2 is 1, so that's 1 or 3i. So there's the next guy, 3i. And then the third one, cosine of pi, would be -1, but 0 for sine, 3i times 0, so this would be -3. And the last one would be, of course, probably the conjugate of that one. Let's see if it is. 3 times cosine of that, which would be 3 times 0, plus 3 times 3i times, what would that be? Down, which would be -1, and the answer would be -3i. Check it out. 4 answers. 3i, -3i. Just like the fundamental theorem of algebra stated there should have been. Okay? Now, each one of those two were set equal to a real number, and we had to change it to a complex to be able to figure it out. In number 5, you would do exactly the same similar idea, except that the problem that you would end up with would be that you would want to write this as x to the third is equal to 0 minus 64i, and that would actually be primarily going down. That's where that location would be. So if I wrote that in polar and then took the actual third root of it, I'd be dealing with this -64 distance is really 64. That's how far away it is in terms of that argument. Cis of 3 pi over 2, all raised to the 1/3 power. And each one of these is going to generate an answer that we're going to get. That first primary complex root will ultimately be the third root of that. I think that's 4. 4 cosine, not cosine. Let's write it in shorthand. 4 cis of 1/3 times that, which would be pi over 2. Check my work there. Make sure I'm solid there. Pi over 2. Does that sound right? Dang it, G. You are right. It is pi over 2. Now, we're going to have to find 3 roots of unity from the primary. So let's see what we got to come up with. That would be 2 pi divided by 3, because we're taking the third root. And if I add 2 pi over 3 to that, now here's the thought here. We've got pi over 2's and we've got 2 pi over 3's that we're going to end up adding. And if I want to get those, I'd probably want them in sixths. So that would be 4 pi over 6 is really what we're going to be adding on. And pi over 2 happens to be 3 pi over 6. So the next one would be 7 pi over 6. And if I add on another one, that would be 11 pi over 6, are going to be the other two answers. And each one of those is 4/6 of that. And we could actually write those in polar if we really wanted to. And it turns out that every single one, or rectangular, every single one of them is imaginary. And that doesn't surprise me. It was like taking the cubed root of a negative I. Weird. Okay? Got the idea? Key part to any of these complex solving questions is that stage right there. Make sure that you're writing the original question as an imaginary, and here it is again right here, as an imaginary as an imaginary rectangular, and then change it into polar complex, and then take your DeMoivre's root application to it, and you should be just fine. None of that seems even remotely surprising. All right, give these last ones done in 6.5 a try, and more often than not, the best thing you can be doing right now is going back to 6.3 and starting your review, because you've learned so much in polar that you really need to go back and make those synapses in your brain working again. See you later.